Aha! This is section 6.4 for the grade 8s. I said if the video was up before 5 o'clock, it is homework. So your job tonight is to go through all these questions, make sure you did all of them properly. And tomorrow when we talk about it, I should be able to pull up your work and you have all the things done, including the questions you struggled with because you copied down the work when I do a homework check. Question number 1 says, Henri multiplied 2.5 and 3.25 as follows. He took the whole numbers 2 and 3 and he multiplied them together to get 6. And then he took 1/2 and 1/4 and multiplied them together and got 1/8. So we put them together and got 6 and 1/8. What mistake did Henri make? Well, the long and short of it is you don't multiply fractions that way. And we used an area model to explain that when you have 2.5 and multiplied by 3.25, you actually multiply 2 by 3, and you also multiply 1/4 by 1/2. But the parts you also have to multiply, so you have to multiply 2 by 3, and you multiply 1/2 by 1/4, but the 2 also has to be multiplied by the 1/4, and the 1/2 also has to be multiplied by the 3. So in effect, he only did half of his multiplications. Now there is an easier way to do that, and what should he have done instead? Well, for B, he should have taken 2.5 and changed it to an improper fraction, changed 3.25 and changed it to an improper fraction, and then simply multiplied it using the procedure that we talked about. Take your numerators and multiply them together. Take your denominators and multiply them together. You get 65 over 8, which is an improper fraction. Then say, well, how many 8s in 65? There's 8 of them. That's 64, which means there's 1 left over. And your answer is 8 and 1/8. Question 2 says to express 4 and 2/3 as an improper fraction, Naomi determined the numerator by calculating 3 times 4 plus 2. Explain why Naomi's method works. Well, here we go. I'm going to draw 4 and 2/3 first. So here is 1 right there. That's 1. And I'm going to quadruple it. There's doubling it, tripling it, quadrupling it. This picture represents that 4 right there. And in addition to that 4, I also have an extra 2/3. There's 1/3 and there's 2/3. So this fraction, as I've drawn it, is 4 and 2/3. But when I ask myself, this 4 that was here, if I ask myself how many thirds, I shouldn't put it like that, I should spell it out, thirds, T-H-I-R-D-S, are there? And the answer to that is, well, this 1 has 1/3, 2/3, there are 3 thirds here. Right? There's another third here, there's another third here, another third here, and 7, 8, 9, 10, 11, and 12. There are 12 thirds that make up this 4. And that makes sense because 12 divided by 3 is 4. So if I thought of that as an improper fraction, that would also be 4. But I also have an additional 2/3, which means I have to add an additional 2/3 onto that to give me the answer of 14 thirds. So 4 and 2/3 as a mixed fraction is equal to 14 thirds. And why did Naomi's method work? Well, when she multiplied the 3 by the 4 to get 12, she was actually saying, how many thirds does this form have? And the answer being 12 thirds. And then she added 2 more because she was remembering this part. And that's how her reason or her method works. So if you take any mixed fractions, for example, 1.5, if you multiply the 2 by the 1 to get 2, and add 1 more to get 3, that will work to change any mixed fraction into improper. Question 3 says, Maura multiplied 2 1/3 by 2.5 as follows. She said, I'm going to change 2 1/3 into 7 over 3. I'm going to change 2.5 to 5 over 2. So far, so good. She did the right things. But here's where things went a little bit askew. She then said, hold on, I'm going to use a common denominator of 6. Now, she doesn't need to do this, but it doesn't really affect the answer. We'll see why in a second. So 14/6 is exactly the same thing as 7 thirds. And 15/6 is exactly the same thing as 5 over 2, or 5 halves. So when she multiplied the numerators to get 210, and multiplied the denominators by to get 36, she then could change this 210 over 36 into... what did you do here? Oh yeah, reduce it to lowest terms. So she divided by 6 and 6 to get 35 over 6. How many 6s are there in 35? There's 5. with 5 left over. So the mistake she made was she did not need to find common denominators. Now the thing is, and we need to understand this, is if I could erase this, hang on one second. If I think about this, this question here, because these two fractions are equivalent, just larger, then this product should work. But the only difference is you don't need to have a common denominator, which means by not finding the common denominator, you kept your numbers simpler, right? So she made it longer than necessary by finding common denominators, because if she didn't, she would have just multiplied her numerators and multiplied her denominators and got 35 over 6, which still would have gave her 5 and 5/6. Question number 4 says express each improper fraction as a mixed fraction or mixed number. So 11/3 is improper. So really what we're asked to do is how many threes in 11? The answer is 3. That is going to be your whole number. Well, how many is 3 threes? That's 9. I'm going to subtract to get 2. So my remainder is 2. That is going to be the numerator. And whatever your denominator was here, it's going to stay the same down here. So your answer is 3 2/3. For 17/6, how many 6s are there in 17? There's 2. That's your whole number. 2 6s is 12. Remainder 5. That 5 will be your numerator over the original denominator of 6. How many 2s in 25? There are 12. Remainder 1, which means 12 is your whole number. The remainder goes there, and your denominator stays the same. And finally, how many 5s in 8? There's 1. Remainder 3. So your answer is 1 3/5. Question 5 is the reverse, and we just talked about it in question 2. How do I change these mixed fractions improper? So I'm going to multiply 4 by 4 to get 16. 16 plus 3 is 19 over 4. That is 4 3/4 as an improper fraction. I'm going to first take my denominator and multiply 8 by 2 to say 16. That's 16/8, which is valued at 2. 16 plus 7 more is 23/8, which is your answer for that one. I have 18 plus 1 is 19 over 3. And we have 21 plus 4 is 25 over 7. Question 6, use a model to determine each product. So for the first one, A, I think we already did it before, but the length is going to be 1 1/3. So the distance from here to here is 1. The distance from here to here is 1/3. And this whole side here is going to be 3/4. So 1 1/3 multiplied by 3/4 will be the area of the entire rectangle. But what we're going to do is we're going to break it up into two parts, part A and part B. And A plus B will be equivalent to the product of 1 1/3 times 3/4. So A has a dimension of 1 by 3/4. So the area of A is just 3/4, because anything times 1 is 3/4, or itself, excuse me. And B has a width or a length of 1/3 and a width of 3/4. So B will have an area of 1/3 times 3/4. Now, we could multiply this out to get 1 times 3 is 3, and 3 times 4 is 12. And then say, hold on, 3/12 is not lowest terms. Oh, hang on. 3/12 is not lowest terms. In lowest terms, both are divisible by 3. I get 1 over 4. So the area of B is 1 over 4. And then I'd say A plus B should be the equal to 1 1/3 plus 3/4, because they're the parts of the area. And therefore, 3/4, which is A, plus 1/4, which is B, equals 4/4, which means your answer is 1. Now remember, I could check it by using the easier method, which is convert this to a improper fraction, which is 4/3. 4/3 multiplied by 3/4 will be 12 over 12, which is still equal to 1. Part B says 2 1/2. This is going to be 2, and this will be 1/2. Multiplied by this distance here will be 1, and the remainder of the distance will be 3/5. So this time, instead of having two parts, we're going to have 4. We're going to have an A, a B, and a C, and a D. And 2 1/2 multiplied by 1 3/5 should be equal to A plus B plus C plus D. So all you do is find the parts of A plus B plus C plus D, add them together, and we'll have the same product as 2 1/2 and 1 3/5. So what is the measurements of A? Well, A is 2 by 1, which means the area of A is 2. B is a half times 1. A half times 1, or anything times 1, is a half. So that's the area of B. C is 3/5 by 2. A section 2, a 6.1 question. If you had 3/5 and you double it, you would have 6/5, or 1 1/5. Now, an easier way to multiply a fraction by a whole number, so instead of doing 3/5 multiplied by 2, we can think of 2 as being a fraction, and that fraction being 2/1, because 2/1 is the same thing as 2. And the reason why that's easier is because when I write 3 3/5 times 2, I can multiply my numerators and multiply my denominators to get 6/5, which would give me the same answer of 1 1/5. The only problem is I don't have to do a lot of thinking. I just use the basic technique for getting the answer. And the last question, D, it is 1/2 times 3/5, which would be 3/10. So all of the areas, if I take my highlighter here, area A is 2, area B is a half, area C is 1 1/5, and area D is 3/10. And if I add those four together, it should be the same as the product of 2 1/2 and 1 3/5. So 2 plus a half plus 1 plus 3/10. I'm going to take this 1 and this 2. Oh, I made a mistake there, sorry. 1 1/5. Oh, that's not right. 1 1/5 plus 3/10. I'm going to take this 1 and this 2, and I am going to add them together to get 3. So I'm not going to worry about those anymore. I got 3 for the whole numbers. The next part is to take a half and a fifth and 3/10 and add them together. So we learned in grade 7 that when you add fractions together, you require a common denominator. So between these three, 2, 5, and 10, the common denominator will be 10. 5/10 and 2/10 and 3/10. And if you don't know how to make equivalent fraction, remember you multiply the 2 by 5 to get that 10. You multiply the 5 by 2 to get that 2/10. And 3/10 stays the same. And once you have them all with the same common denominator, keep the denominator, add your numerators, and your answer will be 10/10, which is equal to 1. So these three fractional parts add up to be 1, plus these two whole numbers, which added up to be 3, means your final answer for what they will equal is 4. So therefore, 2 1/2 times 1 3/5 will equal 4, just as a regular number. Let's check. We're going to check by cheating here. So 2 1/2 is 5 halves, because 2 times 2 is 2, plus 1 is 5, 5/2. Multiplied by 5 times 1 is 5, plus 3 is 8, 8/5. When I work that out, 5 times 8 is 40, 2 times 5 is 10, and 40/10 in lowest terms is 4. Part C, 1 1/3, so I'm going to make the length 1 1/3, multiplied by 1 1/2. That'll give me 4 parts, an A, a B, a C, and a D. A will be 1 times 1, which is 1. Actually, I should do that over here. A equals 1 times 1, which will be 1. B will be 1/3 times 1, which is a third. C will be 1 times a half, which is a half. And D will be 1/3 times 1/2, which multiply the numerators, you get 1, multiply the denominators, you get 6. So when I take those 4 parts, 1, 1/3, 1/6, and 1/2, and I'm going to take those 4 numbers and add them together, that will be the same as the product of the 2. So 1 plus 1/3 plus 1/2 plus 1/6. I won't worry about my whole number. I'll bring that down here, 1. And I'll just worry about these 3 fractions. Common denominator for 3, 2, and 6 will be 6. An equivalent fraction will be 2/6. An equivalent fraction will be 3/6, and 1/6 will stay the same. Now that you have common denominators, keep your denominator and add your numerators. You're going to get 6/6, which is equal to 1. This 1 that we brought down already has to be added to the sum of the fractions, which is 1. So therefore, your answer is 2. And therefore, 1 1/3 multiplied by 1 1/2 should equal 2. We'll check our answer. Change 1 1/3, so we got 3 plus 1 is 4. 4/3 multiplied by 3 over 2. Multiply your numerators to get 12. Multiply your denominators to get 6. And 12 divided by 6 is 2, so it does work. And finally, D. We're going to take our width here. We're going to make our width 2. From here to here is 2. And the rest of it's going to be a half, or 2 1/2. This distance from here to here will also be 2. And the remainder of the distance will be a quarter, giving us 4 parts to our area of a rectangle. Part A will be 2 times 2, which is 2. Part B is 2 times a half. Now remember, if you have a whole number and you're multiplying it by a fraction and you can't do 2 times a half, think of 2 as being over 1. That's still 2. Multiplied by a half. 2 times 1 is 2. 1 times 2 is 2. So 2 times a half is equal to 2 over 2, which is equal to 1. C will be a quarter times 2. And again, same process. So if you go back here, you say, what's a quarter times 2? I can't multiply fractions by whole numbers. So a quarter multiplied by 2 will be as a fraction 2 over 1. Multiply your numerators to get 2. Multiply your denominators to get 4. Express this in lowest terms. 2 over 4 in lowest terms is equal to a half because both numerator and denominator are divisible by 2. So that's going to equal a half. And finally, D will be equal to 1/2, which is this distance, multiplied by this distance, which is a quarter, will equal 1/8. This is kind of an easier question because now our A is 2, our B is 1, our C is a half, and our D is an eighth. So 2 plus 1 is 3. Use your common denominator of 8 here to get 5/8. Attach that to your 3, and your answer is 3 5/8. Okay, so 3 5/8 is the answer. So therefore, 2 1/2 times 2 1/4 equals 4 5 3. Oh, that can't be right. I made a mistake somewhere. Oh, it's supposed to be 4 here. Oops, daisy. Oopsie daisy. It should be 5 5/8. Should equal 5 5/8. Double check our answer by changing them to improper. So 4 plus 5 over 2 multiplied by 9 over 4 will be 45 over 8, which in a mixed fraction is 5 5/8. Question number 8 says calculate. So we have 4/5 times 4/5 times 10/7. Now remember, last time we said if you were starting with products of fractions that can be cross-reduced. So in this case, the 10 being over the 5. If I think of those as being 10 over 5, remember we said we can think of it as being a fraction as itself, 10 over 5, and that will reduce down to 2 over 1 because both are divisible by 5. So with that said, 10 over 5 will reduce down to 2 over 1. Now when I multiply my numerator, it's going to be 4 times 2, not 4 times 10. And 1 times 7 instead of 5 times 7, giving me 8 over 7, which is equal to 1 1/7. So your answer is 1 1/7. However, if you didn't cross-reduce, 1 1/7, then you would have done 4 times 10 and 5 times 7, which is equal to 40 over 35, which is equal to 1 and 5 over 35, which is equal to 1 1/7 because both are divisible by 5. So you could have done that without cross-reducing and still got the same answer as well. The second question, B. Oh, hang on. There we go. My eraser's not working real well. B says 5 times 3 1/4. So 5 is a whole number. And again, when you have a whole number, don't forget, just put it over 1. That's still 5. Multiplied by, well, 3 3/4 as a mixed fraction. 4 times 3 is 12. Plus 3 is 15. You have 15 quarters. Can't cross-reduce, so I'm going to go 5 times 15 is 65, right? 5 times 15 is 65. 1 times 4 is 4. How many 4s in 65 without going over? There is 16 of them. That's 64. Plus 1/4 is your final answer. And finally, question C, change them to improper. So 2 1/5 is going to be 11/5 multiplied by 5 over 3. Now, if you don't cross reduce, you're going to get 55 over 15, which is equal to 3 and 10/15, which is equal to 3 and 2/3. That's your final answer. But if you cross reduce, the 5 over the 5, if I think of it as being 5 over 5, that will reduce down to, because both are divisible by 5, 1 over 1. So this can be a 1 over 1. And when I do that, I'm now going to get 11 times 1, which is 11, and 1 times 3, which is 3, and 11 over 3 is still 3 and 2/3. Question 10, 2.5 laps of a running track equals 1 kilometer. So if I do 1 lap and another lap and a half a lap, that's equal to 1 kilometer. So in order to go 3 kilometers, I would have to do, that's 2 kilometers, that's 3 kilometers. Or 2.5 laps each multiplied by 3 is your question. How many laps would equal that? Well, I'm going to change this 2.5 to 5 halves multiplied by 3 over 1, which is 15 over 2, which is equal to 7.5 laps. Now, alternatively, you could have taken your 3 and thought of it as an area model. So if I had 2.5 here and 3, I could multiply my 2 by 3 to get 6, and my 3 by a half to get 1.5, and put those together, and I still would have had the same answer of 7.5 laps. Question 11, Earth turns on its axis once every 24 hours. How many hours does Earth take to complete 2 1/4 terms? So 2 1/4 multiplied by 24. 2 ways to do it. You can take 2 by 24 and 1/4 by 24, just like our area model would be. So we have 2 1/4 times 24. 2 times 24 is 48. And 1/4 of 24 is 6. So therefore, altogether, it would be 54 hours. 54 hours. Or change this to 9/4 multiplied by 24 over 1. Now, if you cross reduce, this becomes 6 over 1. 9 times 6 is 54. 1 times 1 is 1. And you still end up with 54 without needing to do much thinking at all. Now, if you didn't cross reduce, it made it so difficult. 24 times 9. 24 times 9 is 216. You got 216 over 4. And they're like, oh, God, this has got to be reduced to lowest term. So I said, well, divide by 2. And I got 108 over 2. And then you say, well, I can divide by 2 again. And I get 54 over 1, which is 54. So if you didn't cross reduce, you still got 54. Question 12, on a day in Winnipeg with 10.5 hours of daylight, it was sunny for 1/3 of that time. So 1/3 of the 10.5 hours was sunny. So since of means multiply, this is really a fraction multiplied by a mixed fraction, or 1/3 multiplied by 21 over 2. If you cross reduce 21 over 3, if you think about 21 over 3, that will reduce down to 7 over 1, which will mean you get 7 over 2 as a final answer, or 3.5. So therefore, how many hours was it sunny that day? It was sunny for 3.5 hours. Question 15 says Andreas, whatever, has $18. Bonnie has 1 2/3 as much as that, as Andrea. Cheryl has 1 3/5 as much as Bonnie. So what we're going to do here is I'm going to put an A for Andrea, a B for Bonnie, and a C for Cheryl. So Andrea, we know, has $18. Now Bonnie has 1 2/3 times as much as Andrea. So 1 2/3 times as much money as Cheryl has, which is $18, will be, as an improper fraction, 5 over 3 multiplied by 18 over 1, which, because I love to cross reduce, 18 over 3 will become 6 over 1. Therefore, Bonnie will have 30 over 1, or $30. So Bonnie has $30. 1 2/3 is the amount that Andrea has. But Cheryl has 1 3/5 times as much as Bonnie. So 1 3/5 times as much as Bonnie. And since Bonnie has $30, that would be 30. 1 3/5 is in mixed fractions, 8/5, multiplied by 30 over 1, because we're going to make that whole number a fraction. I'm going to cross reduce because I can. 30 over 5 will become 6 over 1, which means I'll have 48 when I multiply my numerators over 1, which is $48. Now remember, the question is, how much money do I all have together? So your answer will be $18 plus $30 plus $48, which will be $48 there plus another 48. The answer is $96 is what they have together.